Let's take a look at projectile motion. In particular, we are going to pay attention to horizontally launched projectiles. Before that, let's recall that projectile motion is two-dimensional motion made up of horizontal and vertical motion. So the key understanding of projectile motion is that you can analyze this two-dimensional motion as two independent one-dimensional motions. That means the horizontal motion and the vertical motion can be analyzed independent of each other. So if you look horizontally, what the projectile is doing is simply it is moving at a constant velocity. Because there is no force in the horizontal direction, so there is no acceleration, so the velocity stays constant. Whatever speed you give it to it initially, that stays constant throughout the motion. Vertically though, it is moving under the influence of gravity. So that means it's really in free fall. Since we know how to solve free fall problems and we also know how to solve constant velocity problems, we are going to treat horizontal like a constant velocity problem and treat vertical like a free fall problem. So let's look at a projectile that is launched horizontally from a certain height, like this. So what will be the path of the projectile as it falls to the ground? So let's look at this simulation. Let's launch this projectile horizontally from a certain height. And you can see that it takes a parabolic path as it falls to the ground. So I set the simulation so that the speed with which it comes out is 18 meters per second and the height from which it is launched is 9 meters. So let's see how to solve for how long it stays in air and other details about this problem. So the speed is 18 meters per second and this height from which it is launched is 9 meters. And we know that it takes a parabolic path and falls to the ground. So I want to solve for t, which is the total time it stays in air. And I also want to see how far does it land away from where it was launched. This horizontal displacement is also referred to as the range of the projectile. Okay, so we need to analyze this as horizontal and vertical separately. So let me make two columns so that we do not confuse variables of the horizontal with the variables in the vertical. So along the horizontal direction, I know that the velocity is 18. So I'm going to write it as v suffix x as 18 meters per second. And that's the only thing that I know. I do not know what is delta x. I don't know the time. Along the vertical, I know that the displacement, it started here and ended up on the ground. So the displacement, which I can call as delta y, is -9. And the reason why I'm writing -9 is because it's a downward displacement. I also know that the vertical motion is free fall, so the acceleration it experiences is -9.8 meters per second squared, which again is in the downward direction. We also know a third variable about the vertical motion. Because it was only shot horizontally, vertically it just dropped. That means the starting velocity in the vertical direction is 0 meters per second. And we know that if we have three variables, we can solve for any other variable that we want to solve for. So we can solve for the time. Or in short, we need to understand that the height from which it is pushed away is what is going to decide how much time it takes to fall. That makes sense because if you pushed it from a smaller height, it's going to fall to the ground really quickly. So this is the deciding factor for time. So what equation can we choose? So we can choose the displacement time equation. So substituting, we are going to call, because we are in the vertical, we can call this as delta y. So that is going to be -9 My VI is 0, so 0 times time is going to be 0, so this whole term becomes 0. A is negative 9.8 delta t squared divided by 2. So multiply both sides by 2, you will get negative 18 equals negative 9.8 delta t squared. Divide by 9.8 and then square root it. You will get the value of time. So take a minute to complete the calculation. So did you get time as 1.36 seconds? So it takes about 1.36 seconds to fall to the ground. Now that I know the time, how do we solve for the range? So let's go to the horizontal equation. I know the speed is 18 meters per second. Do I need to know any other variables in the horizontal direction? Well, we know acceleration is 0, which means that the speed is going to remain constant. So that means every second it's just going to travel 18 meters. So I know if it has been in air for 1.36 seconds, all I need to do is distance equals speed times time. Because remember, there is no acceleration. So I'm going to just say 18 times 1.36 will tell me how much distance it traveled horizontally. So take a minute to calculate the range. If you got 24.5 meters, you did a good job. So what else can we learn about this projectile? So as you can see with this projectile, horizontal speed will always stay the same. Wherever you take in the path of the projectile, the horizontal speed will always be 18 meters per second. Whether it is here or even when it strikes the ground, it is always going to be 18 meters per second. What about the vertical speed? Here it is 0